All right, today we're going to just talk about some angle pairs and identifying them and how to solve problems that involve angle pairs. So angle pairs, as you would hope the word pairs would indicate, are going to talk about specifically two angles, and I've got the definitions up here at the top all ready to go for you. So the first thing to talk about is just adjacent angles. So adjacent angles, not this first picture, but the second picture, they share a ray. So if you look at the two angles, there's a little C and D inside the interior of each. So angle C here uses those two rays. Angle D uses these two rays. And you can see this one here is a shared ray between both of those angles. So those are called adjacent. I sometimes think of that as being attached. Linear pair, two angles that form a straight line. If you have an angle pair like this, angle 1 and angle 2, because what we know about a straight line, those two angles will add up to 180. So any linear pair is also going to be what's underneath here, which is that they sum 180 degrees. Now, complementary, supplementary, we've already talked about these a little bit. They can be non-adjacent, so a little example here, 35 and 55, they just have to add up to 90. So those two are complementary. These are adjacent angles and complementary, 75 and 15 add up to 90. Kind of similar example here with supplementary. These are non-adjacent, but these two are supplementary, they add up to 180. These are a linear pair and they are adjacent and they add up to 180, so that falls into multiple different categories. All right, and then the last one here is vertical angles, which I'm going to write the definition here to the side just to talk to you guys about it. Vertical angles are formed by two intersecting lines, and they form this X shape. So angle 1 and angle 3 are vertical angles to each other. They're right across from each other. And we're going to talk about this over here in this proof in 1 second, but they are actually congruent to each other. Okay. Also, angle 2 and angle 4 in that diagram are congruent, and those are a pair of vertical angles. So 1 and 3 are a pair of vertical angles. 2 and 4, they're across from each other in that X shape, and the special property there is going to be that vertical angles are going to be congruent to each other. So I'm just going to prove that to you really quick. We'll just fill in this proof to the side here. So for my proof, we're actually going to use this diagram over here. So it says that given angles 1 and 3 are vertical angles, right? They're formed by that X shape, which I should not have marked that in that picture. That's what we're going to try to prove, but I'm going to prove to you why these are equal to each other. Okay, so 1 and 3 are vertical angles. That's just given to us. So we don't yet know that they're congruent. We're going to prove that. Okay, now what I can prove, angle 1 and angle 2, if you guys see this, angle 1, angle 2 together, those form a straight line, and kind of the same exact argument is going to be the angle 2 and angle 3 form a straight line. Both of those are the same. So I would take anything here, honestly. These are a linear pair, so I know they're going to be supplementary. They form, you could say that they form a straight line. You can see that in the diagram there. So either one of those would be an okay reason, but that's how I know those are supplementary. And then the fact that they add up to 180, just definition of supplementary angles there. So I'm going to write definition of supplementary. Feel free to abbreviate that. But because they make this linear pair, I know that their angle measures have to add up to 180. Okay, now if you guys see, both of these equations are equal to 180. Okay, so I'm just going to highlight this so you can kind of see where I'm moving this. So all I'm doing in step 4 is I am moving that equation there, and I'm taking this equation and moving it here. They're both equal to 180, so they both have to be equal to each other. And for that step, I would either take substitution, or we mentioned the transitive property. Either one of those I would take for an argument for that. And then all they're doing from step 4 to step 5, measure of angle 2 is on both sides of that equation. So if I subtract that from one side, I have to do the same thing to the other. That's just your subtraction property of equality. But because I did that on both sides, what I'm left with is measure of angle 1 has to be equal to measure of angle 3. And I know that that's definition of being congruent. If the angles have the same measure, then they're going to be congruent to each other. So now, for every instance, anytime you see vertical angles, you could fall back on this proof to show angles that are across from each other like that, forming that X shape. Those are always going to be congruent. Once you prove a theorem, then you can use it. All right, now all I'm doing at the bottom of the page here is just going to talk you through those different angle pairs we just mentioned at the top, and just list as many possible categories as these could fall into. So here, angle 1 and angle 2, definitely adjacent, so they share a ray. And beyond that, I don't have any angle measures or anything like that. So they don't form a linear pair because I have a full line drawn here, but just angle 1 and angle 2 together, if you guys look at that, they don't form a straight line. They're close to it, but not quite. So I think the only category that falls into is adjacent. It doesn't fall into any of these other categories. I can't say complementary or supplementary because I don't have measurements. Now, angle 3 here and angle 4, for sure, those are vertical angles. And again, they don't form a straight line. They don't share a ray. They're totally independent of each other. Here's angle 3. Here's angle 4. No ray in common. They're totally separate. They do form that X shape, so those are vertical. But other than that, I can't find any other category. Now, angle 7, angle 8. These are adjacent, which I'm just going to abbreviate real quick. They're also a linear pair. They form a straight line. And even though I don't have angle measurements here, because they do form a straight line, I do know anytime you have a linear pair, they'll automatically be supplementary there. All right. Letter D. This was actually in our example at the top for the angle measures, but 55 and 35, if you add that up, that equals 90. So those are going to be complementary. And also in that picture, they are adjacent because they share a ray. To form the 55-degree angle would be right there. To form the 35-degree angle, you see I drew over the top of that ray. So they're adjacent because they're attached and complementary there. And then the last one, only category this can fall into, 140 and 40, that adds up to 180. So I can say supplementary here, which I'm going to try and see if I can squeeze that on there. Supplementary, but they are not adjacent, they're not touching, and they're not a linear pair because they're not forming a line. So just supplementary would be the only category for that last example. Okay, so I'm just going to give some examples in this diagram, and they're not an all-inclusive list, like we could have different examples here, but this just says let's name an acute pair of vertical angles. So I don't have much information in the diagram. I do have a 90-degree mark right there, but I'm looking for an X shape. So I have to have two straight lines that intersect to have a pair of vertical angles. So I would go right there and I'm going to say acute, I'm going to say angle 1 and angle 5 here. And I know they have to be acute because angle 5 is part of a right angle, so it has to be less than 90. So I'm going to say angle 1 and angle 5. Okay, now obtuse vertical angles, we would have to use that same set because I don't have any other shape there that forms those two full lines making that X shape. Unfortunately, to do that there, I'm going to have to be a little bit more specific. I'm going to say angle 6, and I'm going to see if I can go over the top of this. So here's angle 6, right? And the angle that would be vertical to that would be that whole angle there, which I've got several angles that go together. So I'm going to use the letters to label that. So I'm going to call that F, G being the vertex, and then C. That would be a set of obtuse vertical angles. Now, adjacent angles, you have a ton of options in this diagram. You really just need to tell me two angles that share a ray. So just as an example, like 5 and 6 would be good. Angle 4 and 3 would be good. As long as they share array, that would be an example. So there's multiple examples as you go around there. Now, linear pair has to form a straight line. So probably the best example without getting into letters, if I go this straight line right here, I can say angle 1 and angle 6. That would be a linear pair. I could do angle 5 and angle 6. Those form a straight line without having to use any letters or anything like that. But you're just looking for just two angles when you have a pair, just two angles that form a straight line. Okay, complementary means they add up to 90. Best option there, I see that 90-degree angle, so I'm going to say 5 and 4. Now, for supplementary, I could use the same examples for linear pairs, so those are going to be the same. So I'd say angle 1 and angle 6. I could say angle 5 and angle 6. And there's other examples there, just trying to give you a basic idea. But supplementary, I have to know they add up to 180. Since the only measurement I have in there is that this angle EGA is 90. I don't really have specific measurements, but I know if they form a straight line, they have to add up to 180. Okay, and we're starting to get a little bit more into proofs, so just some things you can assume from a diagram, and I probably should have mentioned this before we started that proof on the front, but if you're looking just at a diagram that's given to you, things that you can say from just looking at a diagram are what I have here, and then things you cannot say. So this is just kind of important to go over. You can see from a diagram if angles are adjacent to each other, if they share array. You can definitely conclude that. Adjacent supplementary angles, we just did that in our example there when we were talking about where do we have a linear pair. So if you see a straight line and two angles, you can conclude that they're supplementary. And then also, we proved this on the front, if you have vertical angles, we know that those are going to be congruent. So if you see that X shape in a diagram, you can use vertical angles. Okay, now, without markings or given information, you should not assume any of these things from a diagram, even if it looks like it. If it doesn't tell you specifically or mark it in the diagram, don't assume this. So it says angles or segments are congruent. Like even if they look congruent, you can't assume that. You can't assume you have a right angle unless it's marked or given to you. And you don't want to assume lines are parallel or perpendicular, even if they look like it. So we don't want to just assume any of these three from looking at a diagram. Diagrams are there as a reference, and they're not always drawn to scale. So none of these things should we make assumptions about unless we have it marked. Now, we're going to scooch this up a little bit. And you might want to grab a calculator for this, but we're just going to go through real quick and see if we can label some things. And you don't have to do anything in a particular order here. I'm just going to use what we've been talking about. So here, I just highlighted two full lines that form an X shape. So I've got a 90-degree angle marked right there. So the angle 1 is going to be a vertical angle with that. So that's got to be 90. And then there's different ways you can look at this diagram. Here's what I'm going to do here. I'm just going to notice that this is a straight line. Remember, that's something I can make an assumption about. And I'm just going to lay my calculator here so you guys can see what I'm doing. And make it so you can read it, hopefully. Okay, now, see this straight line. I'm going to get angle 3. I know that straight line adds up to 180. So I'm just going to type 180, and then I'm going to subtract 50, subtract 90, and angle 3 has to be the left over there, which is going to be 40. Now, another way I could have done that same problem, if you guys see where angle, I'm going to trying to do this with my pen. I don't know if I can do that very well. Angle 3, though, here, I'm going to do it with my pen this way. There's X shape, 40 and 40. Those would be a set of vertical angles. I can make that same argument. I got another set of vertical angles here. Angle 2 and the 50, so this has to be 50 degrees. I could have also used, here's a straight line. These three have to add up to 180. There's a lot of different options for some of these problems. Okay, for right next to it, two straight lines forming that X shape. these are going to be vertical angles. And so we said vertical angles, we proved that on the front, those are equal. So just to figure out x here, I'm just going to set up and set those two equal to each other. So we're just going to add 2 and divide by 5 there. And that's going to be 16. You'll notice I'm not justifying each step because it wasn't asking me to do that in the problem, but we are using, here I'm using addition property of equality and then division property of equality. I'm just not defending it. So find x, and if you plug 16 back in, that should give that angle being 78. Now this one, vertical angles again. So these guys have to be equal to each other. So I'm going to say 2x equals 76. We're just going to divide both sides by 2 there, and that'll tell us the value of x, which is 38. Okay, and then there's a couple different ways you can do y. What I might do here, just notice right there I have a straight line. So the 76 and the y, those form a linear pair. So if I just take 180 minus 76, that'll give me y, and should be 104. And let's see, the last one here, there's a couple different ways to do this. What I might use, I've got a 90-degree angle here, and I've got a straight line here. So I know these two angles have to be complementary because the 90 and 90 are going to add up to 180, and I do have a straight line there. So a couple ways to do that. I could add all 3 and set it equal to 180, or what I might just do, I'm going to take the x plus 28, and I'm going to take the 6x minus 15. I'm just going to put those together, and I know together those are adjacent and complementary. So I'm just going to add those guys up. So we're going to get 7x. And then if I combine the 28 and the negative 15, we'll get 13. And I'm just going to subtract 13 from both sides here real quick. So I get 7x, and that would give me 77. So x would be 11 there. And then if I want to find the angle measures, I can just plug that back in. So 11 plus 28, this angle would be 39 degrees. And 6 times 11 is going to be 66 minus 15. This would be 51. And then if you just wanted to check real quick, 39 and 51 do add up to 90. Or 90, 39, and 51 all add up to 180 to make that straight line.